Our next topic for this unit is logarithms. A logarithm is an inverse of an exponential function. So notice the exponential version is y equals b to the x, but the log version is solved for x, not y. That's because when you write the equation for an inverse, you need to switch the x and the y. That hasn't happened yet in this case. We have two logs that we use fairly frequently. One is a common log, which is base 10. You will never see that 10 written there as the base. You will just see log of 10. The other one is the natural log, which is base e. You will never see log base e. You will see ln of x, or natural log of x. And then we have some basic properties of logs, which we'll go over in relation to their exponential counterparts. Because a to the 0 power is 1, log base a of 1 is 0. Notice the answer of an exponential is what you're taking the log of. A to the first power is a, therefore log base a of a is 1. Our next one, because a to the x power is a to the x power, we have this log base a of a to the x power simplifies to x. You could rewrite it as an exponential form as well. And finally, if two logs have the same base, then what you're taking the log of must be equal. I want to go back to looking at the conversion between exponential and log forms. Converting from a log to an exponential, you can use what I call the curly law. The base raised to the power of the answer equals what you're taking the log of. So notice b to the x power equals y. So with our introduction to logarithmic functions, our focus today is going to be on evaluating logs. First, we'll just practice converting between log and exponential form. If it's in log form, I think it's a little bit easier. Curly law, 2 to the 5th power equals 32. Our next one is in exponential form. The base of the exponent becomes the base of the log, and then the answer and the exponent switch. So the answer becomes what you're taking the log of, and the exponent is the answer. You can always check with that curly law, 5 to the 2nd power equals 25. Log form, 3 to the 0 power equals 1. D is in log form as well, 4 to the 1/2 power equals 2. Remember, a 1/2 power is a square root. So another way of saying this is the square root of 4 is 2. Our last one is an exponential form. Again, the base of the exponent is the base of the log. When the base is 10, we don't write it. It's the common log. It is understood that the base is 10. The answer becomes what you take the log of, and the exponent is the answer. So to check with curly law, 10 to the -1 power equals 1 over 10. Remember that negative power flips it and it becomes positive. Now let's take a look at evaluating some log functions. Remember, the answer of a log is the power. So what we're really saying here is 4 to what power equals 1. Anything to the 0 power gives you 1. So 4 to the 0 power equals 1. 49 to what power equals 7? Well, the square root of 49 is 7. So rewriting that as a power, we would get 1/2. Part C is an example of how logs and exponentials are inverses. We have a log base 9 and an exponential base 9. Those cancel each other out, leaving us with 4. Thinking about it another way, 9 to the 4th power equals 9 to the 4th power. Part D is the example of a log with the same base equaling each other. You can simply drop those logs and set what you're taking the log of equal to each other. Subtracting that 1 from both sides, we get x equals 7. And our final one, we have a common log. It's assumed that it's base 10 when it's not given to you. So 10 to what power equals 1 over 100? Well, 100 is 10 squared. Since it's in the denominator, the power must have been negative. Here are a few U-try problems. If you keep that curly law in mind, you should be okay with your logs.